Hey everyone, just wanted to welcome you to week 2, module 2 for ME12 Dynamics course. This is going to be motion of a projectile and curvilinear motion this week. So overview, we're going to go over topics involving general curvilinear motion, equations related to that. We're also going to take a look at rectangular components and kinematic vectors and identify some equations when we're dealing with projectile motion. So objectives for this week, upon completion of the module, you should be able to do the following. You should be able to describe the motion of a particle traveling along a curved path. You should be able to relate kinematic quantities in terms of rectangular components of the vectors. So again, we're revealing some vectors now. We also should be able to analyze the free flight motion of a projectile. So before you begin any of these lecture slides, quizzes, or any of the homeworks, what I want you to do is read ahead in advance here in your textbook. Take a look at sections 6, 7, and 8 in chapter 12 of the text. Read those ahead of time. They're going to help you prepare for everything in the lecture notes and the quizzes. Assignments for module 2 for week 2. So now assigning your first homework number 1. This will be due on the 14th by 4 p.m. Make sure you double check back on Blackboard for the format and the guidelines for the homework, what I expect. Take a look at the rubric. Make sure you have everything in order. Scan it as a PDF and then upload it to Blackboard. And it'll be graded on Blackboard using that rubric. If you have any questions as far as this goes, as far as the formatting goes, how to upload it, what I'm expecting, please feel free to reach out to me via email or Teams. Feel free to also drop in. I have office hours scheduled for Tuesdays and Wednesday mornings from 9:30 to 10:30. If those times don't work for you, that's completely fine. I'm around most of the time, and I have Teams loaded onto my phone as well as my computer. So feel free to drop me a line there, shoot me a chat, and we can meet up and figure out what exactly we can do to get our schedules together to make some time for you to go over this. Another thing that we have for assignment this week is reading quiz number 2. So again, this is through Blackboard. Make sure you go through everything there. This is going to be due by the 11th by 4 p.m. So go through that, multiple choice, automatically graded. It'll be right there. You'll get feedback right away. Take a look. I've uploaded my hand solution to these quizzes. If you have any questions on why an answer is what it is or why you got something wrong, please reference back to my hand solutions for these quizzes as well. They'll be posted on Blackboard after you've completed the quiz. So let's take a look at what our first lecture is. There's going to be 2 lectures within this module 2. The first lecture that we're going to deal with here is lecture 2-1, motion of a projectile here. So main objective of this is free flight motion of projectile. How do we analyze this? What are our key equations? So we'll go through all that in our lecture slides. Also reference back in the textbook, and I'll also reference these as I'm going through my hand solutions in the videos attached as well. Activities. Again, first thing we've done is we've assigned homework number 1. Make sure you get that turned in time. Go through some applications, key equations, kinematic equations for projectile motion, problem-solving examples. So with the problem-solving examples, I'll have a video of my hand solution for the example problems, along with a PDF that I've uploaded to Blackboard as well, with my hand solutions to example problems and some of the quiz questions as well. Second lecture within Module 2, we're going to be dealing with curvilinear motion, normal, tangential, and cylindrical components. Objectives for this lecture: determine the normal and tangential components of velocity and acceleration of a particle traveling along a curved path. We also want to determine the velocity and acceleration components using cylindrical coordinates as well. So how do we do this now that we're dealing with different variables for our cylindrical coordinate system? Activities: go through some key applications for these problems. Take a look at normal and tangential components of velocity and our acceleration. Talk about some special cases of motion, how we deal with those. Go through some example problems, and with these example problems, again, you're going to see my video solution and a PDF of my hand solution as well. And last, we're going to look at some velocity and acceleration